Hello and welcome to the 1895 podcast with me, Thomas D.
And me, Rob Cockerell.
I say with me, Thomas D. I'm not doing much of the heavy lifting in this episode, Rob. You've already done most of it, in fact, because we're returning to our Rotterdam CO2 Summit from a couple of weeks ago with our final instalment of this triple header, aren't we?
Yeah, our final instalment for now. What a reaction to last week's episode as well.
Fantastic episode. And you know, it's really great to revisit those events, isn't it? They're my favourite episodes to do, I think.
They are, I think, and they're our favourite bits on the ground, as we know. I love doing those panel sessions, as do you. So, yeah, fantastic. Great reaction to last week's episode. And now let's get into arguably the most contentious topic of those 2.5 days in Rotterdam, DAC.
Yes, we promised this last week, and that is that full DAC panel that you chaired out in Rotterdam with Pól Ó Moráin, Rob van Straten and Matt Atwood. A fantastic session. I don't think we need to introduce it much more, do we? So I'm going to pass it over to past Rob Cockerell to introduce our panel.
I'm delighted to say that I'm joined by three experts in the field for this conversation, so please allow me to make their introductions. Pól Ó Moráin is the founder and CEO of Carbon Collect, a company pioneering in the field of DAC technology. For the past 8 years, he has focused on carbon capture and has overseen the development of the mechanical tree, the world's first passive DAC solution, since 2020. This innovative technology efficiently captures carbon dioxide from ambient air without the need for any energy-intensive fans or blowers. The technology produces a nearly pure CO2 stream at the end of each cycle and contributes to a permanent net negative balance of atmospheric carbon dioxide. Carbon Collect installed its first commercial-scale mechanical tree in Arizona in 2022. Rob van Straten is the CEO of Skytree, as you'll be aware, a company pioneering decentralized direct air capture technology to combat climate change. Since 2022, he has led Skytree's mission to transform how businesses manage carbon by creating modular solutions that capture CO2 at customer sites for utilization or permanent storage. And Matt Atwood is the CEO and founder of California-based Aircapture. He is a technologist, chemist, entrepreneur, and pioneer in the direct air capture space. With over 20 years of experience in renewable and climate technology development and more than a decade in DAC and CO2 utilization technologies, Matt has a proven track record in this field. He has built and commercialized technologies in CO2, water, waste treatment, and biofuels, to name a few examples. Okay, let's begin. We'll have an opportunity for some of your questions in due course, so please do send them in and I'll keep an eye on that. But I'll take my seat for a moment and get us underway with some scene setters here. So I think it's appropriate to come to you first, Rob. I feel like you're always having to defend yourself on this stage, and perhaps that sums up where DAC is actually today. As a topic, and you've done that very successfully, as David acknowledged in the podcast a couple of days ago and on stage yesterday. You convinced him and many others, no doubt. So let's come to you first. And why do we need DAC? You covered this yesterday, but perhaps you can just tell us again as that scene setter.
Yeah, by all means. But I first would like to come back to you, Steve, for your very insightful and inspirational contribution, and actually I agree with everything you said, so I give you that. It was also educational for me, as I always say to investors, we have such a high velocity of innovation, but now I learned that I should say we spent 25 million euro in the past 3 years on things that mostly failed and didn't make it to the final design. So thank you. And I also learned that I should emphasize the many failures in my long career rather than the successes. So thank you for that insight. So first and foremost, we, as I said yesterday, even if we stop all emissions today, even if we catch all CO2 from process emissions and store them, we still have too much CO2 in the atmosphere. And it doesn't even matter if you believe that the Earth is flat or if that is caused by human interventions. I think it's sufficiently proven that climate change is happening, that it's very harmful for people, not for the planet. We are the dinosaur and the meteor. And that we need to reduce the CO2 levels in the atmosphere. And the costs of doing nothing are ever increasing. So the link with CO2 utilization, as I also went into yesterday, is through decarbonization of industries, there need to be other sources, specifically as the demand for CO2 will increase. Only think about e-fuels, and then the demand for surplus CO2 will grow within that growth. And the benefit of combining DAC for both use as well as storage is that utilization of CO2 is a near-term revenue opportunity, and it helps with deployments. I think we're all three on the modular family, so we need deployments, and then utilization offers opportunities to quickly deploy while we're preparing for large-scale removal initiatives.
Fantastic, thank you. And we'll come back to that point around modularity in a little while. But perhaps I should also give Matt and Pól the chance to open up. I've given introductions, but Pól, is there anything you'd like to have as an opening sentiment?
I would agree with most of what you've said. We have to start everything. When you start a new technology, it's more expensive. We see quite big changes in getting down the cost curve. For us, it's a change of materials, so moving away from metal materials. It's the form factor for sorbents. It's trying out and testing as many sorbents as we can to identify the ones that will last the most and the longest. But it's also a balance of cost and sorbent. And the real challenge is efficiency, because a bit like solar, you have what we call the utilization factor. And you don't always get to what you design for. So you design for 100 tons per day on a system. You're probably going to get to 50 or 60 tons in actual, given atmospheric conditions and weather conditions and so on. So we have to be pragmatic about where we start, and an eye on where we need to get to in terms of cost, efficiency, and performance.
Fantastic, and I hope we will be having a pragmatic conversation for the next half an hour or so. And Matt, your opening gambit.
I think on some level the global economy runs on carbon. It's in the food we eat, it's in the beverages we drink, it's in the cold chains, and all across in the fuels, all across various different markets and sectors. And it's very much the case that we need carbon removals. We must remove and reduce the atmospheric CO2 loading beyond reduction of burning fossil fuels. But we also need new supplies of CO2. The CO2 market is growing, demand is growing, in particular certain geographies and regions like in Asia, with supply coming offline substantially. And so there's a growing supply-demand gap that can be filled by on-site technologies like DAC, in addition to the need for decarbonization and getting to scale.
Okay, thank you. So let's come to the first question, if you will. In our podcast 36 hours ago, should we say, we heard a couple of sentiments. So we heard DAC is like air separation, so we like the idea of it. We also heard it's like SAF. We know it can be done, the science behind it, but do we really want to do it, or will we stick to what we know to do best? So Matt, you have a good industrial gas expertise embedded in Aircapture, actually, which I think is pretty cool. With that in mind, what are your thoughts on that, and how do we make DAC happen? How do we stop the debate in these events and say it's here, it's coming?
Well, by deploying the technology and finding customers that are willing to buy the CO2. I mean, I think we have, the way that the CO2 market works is the pricing of CO2 is very much dependent upon the geography and the regionality of the distance between the consumer and the producer. And there's a lot of cost involved in the logistics value chain there. So as we deploy technologies and sell CO2 to customers, utilizing DAC for both utilization as well as sequestration, we could drive the costs down over time as we leverage that to get to scale, as Rob was talking about a little bit ago, and prove the point that this is a profitable technology that can deploy CO2 into markets cheaper than the incumbent industrial gas suppliers, while also providing a sustainability benefit.
Okay, and Rob, You agree with that in terms of how we take it from nice to have?
Well, very, very much so. But I also say this, the debate should not be, should we do biogenic or DAC or process capture? We need all of it. And there's certainly a place for DAC in the bigger CO2 universe. But if you look at, the state of maturity, it's very immature. There's hardly commercial deployments that happened. So let's not kill it before it's born, and give it the opportunity to scale up. And we don't have to populate all CO2 demand with DAC machines. I don't think anybody would argue. And but there's also the circularity of biogenic and atmospheric and oceanic CO2 for that matter, which plays a role and increasingly plays a role, and policymakers are increasingly aware. But there are many use cases where we're in the money, and as Jeff Olioke always says, if you want to be green, you have to be in the black. I think there's enough black in projects around the world to mature this DAC industry. So if we only get to, let's say, the first billion of revenue, that would be a major milestone.
Okay, fantastic. So if we look at that pragmatic approach, we look at the scale-up side of things and whether we can depend on DAC, shall we say. I tried to deconstruct some criticisms actually from Jeff and Luke in the past year and turn that around a bit into questions. So can we rely upon DAC as a reliable source of CO2 supply anytime soon? And what time frame realistically before we can? Who'd like to take that one first?
So first of all, DAC has been around since the 1990s. If you go back to the early work of Klaus Lachner, his influence on the first sort of three companies, Carbon Engineering, Climeworks, Global Thermostat. And I think the big difference between those older companies that have been around 15, 16 years and the new sort of companies coming up is that we're all moving to realization that you need to do small and multiple of small units rather than big buildings and large systems. So I think we are on a different path, if you like, in terms of how you scale, the time frame that you can do that. And for us, and I think for most of the modular-based systems, it's a case of trying to get your cost efficiencies, your material efficiencies, your sorbent choices, and so on, at a single level first, then at a group level, equipment groups and so on, and you build out. But mindful as well that the infrastructure, when you get into larger carbon farms, your piping infrastructure, is a significant, cost factor and part of your capex. So it's not just the equipment itself; it's what you put it on, how you put it together, how those pipes connect, whether you can turn the system up or down, depending on ambient weather conditions. And everyone in this space is beholden to weather conditions. And as a general rule, you're sort of with current sorbents, you're limited to above 2 or 3 degrees C and below 36, 37 degrees C. So site selection is also critical. But once you have a broad understanding of what you need to do, and you start small and you design properly, I don't think there's any really major impediments. And the bigger we go and the more we're manufacturing, the cheaper the unit cost is going to be.
Okay, and if I stay with you for a moment, Pól, I mentioned in your introduction, Carbon Collect installed its first commercial scale mechanical tree in Arizona in 2022.
Yep.
How's that going? What are the learnings?
I would say we've had 2 sort of key learning points. One is just putting that first system up, operating it, testing it, running it, understanding it, optimizing its operation. And the second point, or the second sort of key learning, we did quite a large program funded by the Department of Energy, which is looking at the impact of location, climate. So we did a project where we picked 3 sites in Southern California, Wyoming, and Alabama. We took 15 years of weather data. And it was really around, first of all, doing site-specific characterization, understanding, that utilization factor. Are you going to get 40% or 60% or what is the band of real capture, capacity or capability? And then how do you actually design the physical carbon farm? So we designed, 3 large carbon farms with a nominal capacity of 100,000 tons per year per site. And the sizing of the equipment changes depending on what the ambient conditions are in each of those sites, the weather patterns and so on. So those, for us, are the building blocks, and we as a company now are designing for utilization factor and not peak performance.
Okay, thank you. And Matt, I'll put the same question to you about that sense of reliability. Can we depend on DAC anytime soon? Can we now?
Yeah, we can now. It's a question, I mean, for example, we have over 20,000 hours of operating time on our DAC machines, and we've achieved over 90% reliability and timing of operations. I really think it depends on the use case and where the projects are located, what the costs are, and how much redundancy you want to build into the system. So while it's an early stage technology, you can always make CapEx and OpEx trade-off decisions to ensure reliability. You can increase the size of the tank farm. You can store more CO2. There's many ways that you can solve that problem. So it's not. I don't believe it's so much as is the technology mature enough. Different DAC pathways are at different technology maturity levels, but it's a question of how do you meet the customer's demand, and does the price work today?
Okay, thank you. I'm glad we've managed to get under the bonnet of some of those aspects behind DAC. Let's turn to audience questions for a moment. Hopefully we can get those pulled up on screen. I've seen 2. Perhaps we'll get some more come in as well. Let's have a look. Have we got those? There we go. What a great question to open with here. This isn't emotive, is it? Why do people have such a strong dislike of DAC? And let's add to that. I mean, in theory, it ticks all the boxes, right? We're taking it out the air, we're cleaning things up. So let's get a panel view here. We'll start with you, Rob, because as I said, you seem to defend yourself all the time. Why do people have such a strong dislike?
I think it has to do with human nature, resistance to change. I remember when I was in the EV charging business, and tirelessly people explained to me that they would never drive an electric vehicle because, then you have range anxiety, right? And then I counted the question and said, but how often do you drive more than 300 kilometers a day? Oh, when you go on holiday. Okay, so let's unpeel that onion. So how often do you stop when you travel to the south? Well, stop. So then you charge. I mean, it's perception more than anything else, I would say. Resistance to change, disbelief because there's so little proof, because the technology is not that complicated, but it's uncharted territory, so it takes a while before companies like us are mature enough to prove through large field installs. But I must say, there's also a lot of people that do like DAC.
Okay, fantastic. And Matt, is this something you face? Is perception a problem?
Yeah, I think it's certainly the case that perception is a problem around DAC. I mean, I think, if you look historically, there was, for example, a report put out by the American Physical Society saying that DAC could never be done at under $800 a ton. But they got some fundamental analysis of the thermodynamics and the kinetics of the processing wrong. And, most chemical engineers are taught, well, it's cheaper if you separate something that's higher concentration than lower concentration. And why should we get behind DAC when we should be decarbonizing fossil energy plants and we should be reducing, doing post-combustion capture? And the answer is we need to do all of it. And as we do more DAC, we'll drive the cost down. And there will be places where DAC can really answer some questions and solve pain points within the market that can't be done otherwise. So I think, as Rob was saying, over time, as the technology matures and as more use cases get demonstrated and shown, and as technology operators are more and more transparent about what the costs are, what the energy demand is, I think perception will shift over time.
Thank you. And yep, we heard about the need for transparency earlier. Pól, your thoughts on this? The pain point?
I think fundamentally what we're really doing is a waste management exercise. If carbon dioxide had a color, if it was a solid and people were just throwing it out in the street, people would react and respond quite fast. But it goes into the atmosphere, we can't see it, we can't touch it. So it's been sort of out of sight, out of mind. The reality is that the emissions, both the historical emissions, which is a separate sort of issue, but current emissions as well, is just at such an extreme at this stage that you either do you wait till it gets too bad before you start doing anything, or do you get ready first and be prepared? And I think the pragmatic thing is that you start small. We've been talking a lot over these 2 days around utilization. To me, that's quite an important part, and it's like any type of waste. You have an element of permanent disposal, recycle, reuse, and this is really no different. It's just a different type of product.
Absolutely. Okay, thank you. Thanks to the whole panel for that question. Let's look at another contentious point, and we've heard about this a little bit. Will permitting and permissions always be a problem that could ultimately hold DAC back? Rob?
It's an issue for sure for most of the applications. Permitting for our customers in storage, they are operators. They need to have a drilling license and local permits. But if you look at another sector like greenhouses here in the Netherlands need a permit to put such a big machine out. And our first customers found a very willing government that very quickly, very unusual for our country, gave permits to install these machines because they want that technology to be part of the technology stack of greenhouses. So it's a mixed landscape, I would say.
Okay, thank you. Any other views on that question?
Well, I think the whole issue of location, if you take sequestration as an exercise in the US to drill one sequestration well, and you need more than one well, you need an inspection well as well as an injection well. But you're talking about $2.5 to $3 million per well. If you go to Africa, it's about $500 or $500,000 rather. So you can do the same in different locations at different price points. The advantage, or one of the advantages of DAC, is that you're not tied to a specific location. You either want to be at the point of reuse or at the point of disposal. So either sitting over a saline aquifer or sitting next to a use case. And where that happens, is a pretty open question. We're certainly seeing a lot of global interest. It's not just Europe and it's not just the US.
Okay, and then that's actually quite a good segue. We'll change the question around here slightly. So Adam Forsyth has asked, for each technology, is it better to locate for the energy purposes or for the CO2 offtake?
I can start. So the sweet spot is actually the intersection of access to renewable energy and then a destination, a downstream destination, whether it's storage or usage. And as I explained yesterday, also our press announcement of this week, if you start with abundant energy, then that's even better because you prevent negative prices, you don't compete with communities or industrial areas, and there are many of these sweet spots, whether it's for use or for storage. If you connect with waste heat from an industrial site, perhaps co-locate near CCS infrastructure, those are all excellent circumstances. And again, if we only focus on those as a DAC industry, then that's a lot of business.
Okay, thank you. And Matt, I think I'll come to you for this one because I referenced the industrial gas expertise within Aircapture. We've got this question here from Stephen. Should DAC at a large scale be a standalone system, or would it be better to integrate in existing ASU plants?
I think both cases make sense. I don't think it's binary and that it's better or worse to do either. It really depends on what is the use case. Is it sequestration? Is it utilization? Is it industrial insetting to reduce to reduce Scope 3 emissions? And how do the economics bear out relative to what is the customer willing to pay for carbon? What do they value the decarbonization benefit? And what's the cost of energy? Certainly, integration with industrial processes where you can recover a large percentage of the energy you need to run the process from like waste heat streams is very beneficial. it will reduce the cost substantially of the process, and we've done some feed studies looking at this and proven that case out. But the question is, where is the CO2 market? Where is the demand, and how do you get it to market? And that's not trivial relative to where some of the kind of low-hanging fruit integration infrastructure opportunities are.
Okay, thank you, and hopefully that's answered that question in the audience. A final audience question then for a moment. Purity inevitably and rather understandably is always an undercurrent of these events when we're talking about CO2. So looking into the future, is DAC captured CO2 always going to be more quantity than quality in that regard? Who would like to take that one first? Okay, Rob, you
go ahead, Paul.
So I think when you compare point source capture to direct air capture, we have a cleaner stream. Generally, with direct air capture, you're not picking up contaminants. So it's nitrogen, small amount of nitrogen, and in our case, we're 95% pure CO2 just coming out of the box before we do any upgrading or processing of that. The 5% is nitrogen and some water vapor, essentially. And it's not, a difficult process to knock the water out or, to get to a high purity CO2. So I don't think quality is an issue. Depending on the use case, if you're talking about utilization, where we talk about sequestration into concrete, for example, you need about a 65-70% purity level. Greenhouses, I would imagine around the same. So it depends, are you going to food grade, are you going to, if you're looking at permanent sequestration, you have to be bone dry, no oxygen, no moisture content, because that causes problems when you go downhole. So it really depends on, are you permanently disposing or are you reusing, and what the requirements, specific requirements. We've been doing trials, for example, with stack to algae cultivation, for example, and that's quite dilute. It's quite similar to greenhouse use, for example.
Okay.
But in general, I would say purity is not an issue.
Okay, and Rob?
No, I agree with that. Our purity out of the box is above 98%. We didn't know that. We found that out by measuring field installs. But then it's about the purity. If you're high purity gas, it's easy to liquefy. It's more cost effective to liquefy, so we can choose both gas or liquid CO2, but it's also about what else is in there, as I think you were referring to. So we've done an 8-month trial with the Wageningen University here in the Netherlands to see the impact of DAC CO2 on the growth of cucumbers. Cucumbers are very sensitive plants, is what we've learned. They done an A/B test with CO2 from OCAP, from our friends here in the room, in one cucumber greenhouse, and our CO2, and obviously the plants didn't get distressed by the one or the other. So I agree, it's about the source. There are no traces of benzene or this, that, and the other, which you need to validate for food grade, because it isn't there in the first place.
Okay, and I think that often gets lost as well. We don't talk about the other sources that CO2 comes from, of course. Is this question of purity also linked to the purpose of the plant? Because I think that's a point that comes up, isn't it? Is there a danger that if the business case isn't pointed in the right way from the outset, that captured CO2 goes into sequestration rather than utilization? Is that a concern for any DAC projects?
No, it's only adding more revenue opportunity. And again, we're on the modular track, so I think it's indifferent for us, whoever wants to buy these machines, simply said. We do see the transition from process CO2 from use to storage, as Netherlands is one of the leading nations with the Portos project and the Northern Lights project in Norway. So no, it's great. They're all welcome.
Okay. Okay, fantastic. Let's talk about that scale then and that modularity. When I came into this panel, I had hoped to pick up on some of the observations out there around the sheer infrastructure and land mass that stereotypically DAC projects require. However, given you're all on the modularity kind of approach, this whole talk around DAC machine versus DAC plants, is a small-scale approach a more cost-effective and perhaps rapid route to adoption for DAC?
Typically, yes. I mean, it depends on, again, it depends on the use case. I think if and the DAC technology pathway, there are certain technology pathways that require large-scale infrastructure to be capital efficient or energy efficient. But in the case of what we're doing, we're modularizing everything into shipping containers, and you want to reduce the balance of plant costs relative to what the scale of the offtake is. So if you're looking at larger scale sequestration, the question is, how do you pack these machines efficiently? How do you reduce balance of plant cost for piping? How do you run this efficiently so that the machine next door isn't sucking in the exhaust from the previous machine? So that part can be non-trivial and requires really intelligent engineering to pull off. But if it's simply converting CO2 into products or selling CO2 or on-site production of CO2 at reasonably small volumes to beverage companies, et cetera, a much lower threshold of requirement to design the required kind of integrated balance of plant.
Okay, and is this also a perception challenge, Rob, that everybody does just think of the huge plants and the projects and the land mass, but actually this can be done on a smaller scale?
Yeah, it's also what you referred to, Paul, is the first generation of DAC companies, they build plants, right? And that comes with a couple of consequences. First of all, a low velocity of innovation, because every 3 years you build a plant. Well, I think we develop iterations in 3 months. So the speed of maturing this technology is much higher if you build machines versus plants. But I think I referred to it yesterday as well. When you follow a machine approach for a large site, I've been involved in these cost calculations, then there's a lot of extra cost for a site, which refers to, for instance, the cost of capital. So there's all sorts of risk premiums that are applied on a plant, because you don't know until you build the plant. And the big benefit towards the cost of capture and storage or large-scale e-fuel projects is that you can put a machine there, measure the data, take out the risk premiums on the EPC side and on the financing side. And that's probably a substantial cost reduction versus the concept of building plants. And I've seen cost of capital varying from 30% of the total cost of the whole facility to also zero for a Middle East oil company that puts their cost of capital at zero. But it does matter. And you can't really predict until you install, because as I think you said, humidity, temperature, even altitude plays a role. So you have to put a machine there, measure the results, and then design your plant and calculate your cost.
Absolutely, thank you. So I can see we've got a couple of minutes left on the clock, so perhaps time for one final message, shall we say. I was interested to note in the poll results I showed this morning, in terms of the new sourcing pathways, biogenic was clearly streets ahead, more than 80% of the vote. DAC didn't have quite such a big share, and I'd like to think that we can break through some of these arguments, get under the bonnet, as Steve said, and address that balance somewhat. Maybe in a year's time we'll feel differently. But to that end, if you had one concluding message to share with the room, what would that be? Let's go this way. So Matt, we'll start with you.
I would say, we're at the inflection point of the technology sort of maturation in DAC. I think what we'll start to see is more deployments, commercial deployments, and higher technology readiness as some companies start to scale and start to prove that the technology is kind of ready for prime time. So I would say in a year we'll be having a very different conversation relative to this with a number of the things that are going on in the market.
Okay, thank you. And Paul?
Quite similar to that. For us as a company, we have initial projects here in Europe, in Germany, Ireland, South Africa, United States, fairly global interest in what we're doing and how we go about doing that. I think, if you go back to 2020, we would always start conversations like this with trying to explain the technology. And the real issue now is, people broadly understand. And the question are, really, what cost can you do it at, and how fast can you scale? Those seem to be the critical issues. And I think, certainly for us, the focus has been getting the technology right, getting your costs down in a single, capture unit and so on. We're quite small, 1.5 meters in diameter. We don't use fans or blowers. We're just using wind delivery. So these types of innovations, whether it's what we're doing or what other companies are doing, are starting to have an impact. And what we're seeing now is the companies that are really leading the field getting ready for commercial deployments. And I think over the next 1 or 2 years, we're going to see significant upskilling of just practical deployments, learning from those, and optimization on that learning. And then the whole implementation of AI, machine learning, deep reinforcement learning to further optimize and drive down costs. There's lots of different aspects to what we can do to get to, I'm not convinced that we can get to $100 per ton as an industry, but certainly we can get well under $200 per ton. And I think the time frame for that is, between now and 2030. And we're quite confident, from practical reasons, that we can get there.
Okay, that's good to hear, and hopefully we can pick over some of those positive case studies in the next 12 to 24 months. And Rob, some final words from you?
Yeah, sure. So I think the most skeptical audiences are investors in Europe, that is, and perhaps the gasworld community. I remember that Jeff Holyoke was throwing rotten tomatoes at me a year ago on stage, and I had the opportunity to throw them back the next day. So I think the rating was 4%. We'll take it. 4% market share for DEC. Let's go for that.
Okay, fantastic. Thank you once again to our panel. That does conclude the panel. Thank you to Rob van Straten of Skytree, Matt Atwood of Aircapture, and Pól Ó Moráin of Carbon Collect. And we almost started there, but let's give them a full round of applause, please.